but of course we cannot completely ignore. It will be there, losses are inevitable, but you need to reduce as much as possible. Minimum you have to plan it. So that's a practical scenario that we have to work out. Okay, so that is one thing. You understand, right, how to define this. Now you see, when I keep this thing, no, when the transformer rating goes maybe 95% and above, let me put it 9. Okay, so let's see that it will give warning indications. That means typically it is not recommended to go or load the transformer beyond 95%, beyond 95%, right? You see that here what we are getting is 9.4, right? Let's slightly increase it. So let's slightly increase it. Let's see what happens. So right, so maybe something I made wrong actually. Let's check. Okay, that didn't work out. Okay, so 9.3 I'll put it. So when you put it like that, no, you will come to, so generally during the design stage, you see that it is giving marginal. That means it is almost 95% and above it has come actually, right? So it has come like that, right? So that's the difference, guys. Okay, so that's the your loading. What is the transformer loading percentage here? What is your transformer loading percentage here? So on the LV side, maybe 9274 divided by, so this will be your transformer percentage of the loading, right? On the LV side. When you put it on the HV side, if you look at, no, that means 9765. So this is your loading percentage. See, when it is crossing 95% and above, no, that is why it is showing marginal. So generally, typically the transformer rating actually during the design stage, you can go up to, like, you can load, I mean transformer loading can be during design stage, it will be like 80%. You keep it like that. Then transformer loading can be increased as the, there will be a, during the design stage there will be a up to 95 you can load it, guys, actually. Okay, do not always during the design stage, do not load beyond 80%, because later you may needed it. So always consider that in your mind. Okay, so that is very important. So that's you don't ask me that what is the rule, this thing and all. Basically there's a design good practice. Some companies, they will have this as a rule, or kind of, standard, internal standard, they will have that. Okay, so because they know that practically some sudden loads are may come up because of that, internal workout, or other department will give some load, and various reasons. So some practical consideration they are having like that. Okay, but in technically up to 95% you can load, guys, actually, right? Even beyond it can be loaded, but for certain percentage, because it cannot withstand that much, continuously you cannot load it. For sometimes it can be overloaded with few seconds, like that. Okay, so that's always possible, right? So this you need to look at, right? So that is one thing. Right, so next we'll go. You understand, right, how the sizing has to be done. You see here, if you go here, these people, they have one module called sizing. 1 second, you see, that is just a, see, based on your operating load, no, based on your operating load, like it will suggest something, the value will be suggested here. Let's see. See, when you keep it, no, you see that it is suggesting some size. It is suggesting anything. So, but we have taken the smaller one, that 10 MB, we are taking it, right? So it will suggest, actually you can choose anything, but I, that's what, we can choose anything. So when you have a single transformer, it's up to you that how you want to choose. Selection is like it is it's like you decide, and your customer both should think and discuss, and technically, okay, we'll have it like that. Okay, that's what it is. So there is no hard and fast rule and all, right? So that you can look at, right? So that is one part. Second, but most of the cases, no, when you have the this thing, no, now let's look at the distribution philosophy. See, please remember that this is very important. When I say configuration, right? 1 into 100 percentage loading. Second, 2 into 50 percentage loading. Okay, so we'll look at this scenario. We'll look at this scenario, right? So now let's go with this. See, please remember this, guys. So this is one case. Let me just take this one. So let me just put it here. So in this, no, let's say that we will have another transformer. So we'll have another transformer. Okay. Then ideally what we'll do, so we'll have one bus, bus coupler. So we'll have this bus coupler always open. Now, when you run the scenario, please remember that when you run the scenario, so when you run it here, what happens here? You see, both transformer are loaded 9.3 MVA, but it is overload. Actually, it is like slightly marginally it is overloaded, right? It is above 95%. But ideally, this nobody will go like this. So what they will do instead? What they will do instead, for the purpose of redundancy, see, in this there is a risk. What if you have to take the transformer out for maintenance, then you have to switch off the load. You have to switch off the load, or you have to have the DG set or something, then that's the only option. But here there is an option that, but in this case, you can have a one more transformer that though that then your loads can be put it like that. So your loads can be by default, normally it will be like, half of the loads, right? That is one thing. Here also normally half of the loads. You can keep it like that. So half of the loads, correct? So this will be like that. So now you see here, now there is an option that in this your transformer will be loaded only 50% only. You are not loading fully. You are not loading fully, right? So why it is like that? Why we are doing like that? So whether let's look at here that 4647 divided by, like, you are loading only this much percentage only. Most of the time this will be the scenario, guys. While if you wanted to take the transformer out for the maintenance, let's say that this case I'll put it on service. right? So like I'll take it out of the service actually, right? So this one, I'll close this breaker. Ideally, even if you have one more breaker, ideally here you will have one more breaker, something like that. So now this one you open it. Okay, this one you open it. This one you close it. Now you are loading the like when you take this transformer out, so you can run the entire load in this actually. That is also possible. Most of the case will be like that only, right? Most of the case will be like that only. But this can be done vice versa also, guys. This can be done vice versa also. So it's about how you want. Then there is another possibility as well. There is another possibility as well. What is that another possibility? So this is 33 percentage loading. I mean here you can say like that. Three number of transformers. So this is also possible. So what is that? You see here. So let's add one more bus here. So right. So we'll add one more bus here. See, in an ideal condition, we have a three transformer, right? So this will be like it will be opening, it will be going like that. One second. Yeah, you put it like that. Okay. In ideal condition, what happens? See, all the three transformers, it will be loaded individually, right? Individually, it will be loaded. That means the entire load is divided. Maybe here you see that I have not. It will be like that. So here the challenge is you can connect in a vice versa. Previous configuration also you can accommodate. Previous configuration also you can accommodate. Like if any one let's say that you are taking out this one, you can keep it as a common. This one you can keep it as a common, and when you are closing this you can close it, and this alone you can run it. This can be loaded like that. Okay, so this can be loaded like that. You see that this load also it is coming from here. Otherwise, the vice versa. This also you can close. You can combine these two and you can run it. Right. So this can act as a bridge between both. Anyone like there are some cases very critical applications are there. So at the time they don't want to shut down the plant. They want to multiple flexibility so that they can always run the plant 24/7. So that they wanted to put like that. So this is very important. This is very important. So you must ask your customer what kind of configuration is very how they wanted to run the plant based on the operation point of view. You need to think and you have to add the transformers accordingly. See, in this case, by default the transformer is loaded by uh, typically like it is 3 transformers sharing the load, right? That means you put 100, which means 100 divided by 3. If you put it, no, this will be the loading, right? So you can also keep it like that. So see, what is the point here? I wanted to make it any configuration you can define it, but all are possible. That's what I'm trying to say. You can also discuss with your customer and which one they need. And of course, when you go with this, you will have flexibility is more. Flexibility is more. You can run the plant continuously, even though during the shutdown of any one transformer, still you can, by changing the few modification in the, by switching on, switching off the transformer and breakers, you can run the plant continuously 24/7. But that cannot be done in this. That cannot be done in this.